Okay, so good morning students. Am I audible to you? So good morning all of you. Okay, so see here. So in yesterday's class we have started identifying solutions for system of linear equations. So basically we discussed one method called LU decomposition method, and we have seen how to split the coefficient matrix into a product of a this lower triangular matrix and the upper triangular matrix, and we worked out one question based on that, correct? So let me show you previous phase that we dealt with. So this is the point where we stopped. So we thought we learned how to identify how to solve a system by LU decomposition method. So once we split this matrix A into a product of lower triangular and upper triangular matrix, then we'll assume this product of this upper triangular and this variable matrix as some other variables y, and then finally after calculating we'll be evaluating this x from this product, and that's what we have done here exactly in yesterday's class. So with that given system we identified all these things, and basically we did this analysis. So now we'll continue our discussion. So for the same system of equations, we'll look at something called Gauss elimination method. Gauss elimination method. Okay, so we'll see how to solve a given system of equations in this Gauss elimination method. Okay, we'll consider the same system for which we considered 1, 2, 3, and we'll work out the things. Okay, so see here. X plus y plus z is equal to 6, x minus y plus 2z is equal to 5. Okay, x plus y plus z is equal to 6. I am straight away going with the example because time is short for us actually. X minus y plus 2z is equal to 5, correct? And x plus y minus 2z, I think the third equation. Is this what we have? X plus y minus 2z, x minus 2y plus z. Okay, x minus 2y plus z, x minus 2y plus z is equal to 0. So this is basically the equation that is available for us. Okay, so we'll see this Gauss elimination method, how it happens. So now we'll form the augmented matrix. Means if the system is AX is equal to B, we know the augmented matrix is A augmented B, and let us write this matrix. Okay, so A augmented B is equal to, now if you write the matrix of the A augmentation B, A is the matrix found by writing the coefficients of these equations. So 1, 1, 1, 1, minus 1, 2, and 1, minus 2, 1. And this augmentation here, let us put this dash and let us write this coefficient matrix as well, 6, 5, and 0. Now in Gauss elimination technique, what we do is we generally try to convert this augmented matrix in a row echelon form. Okay, and then we'll see, because if you see this set of matrix, this is coefficient matrix and this is the constant matrix which basically satisfies this condition. Okay, and when we are trying to convert into row echelon form here, we should apply only row transformations, but we can't apply column transformations. Please make this a note. What happens if we apply column transformations? For example, this system is 1, 1, 1, 1 minus 1, 2, 1 minus 2, 1 into x, y, z is equal to 6, 5, 0, correct? And this is the particular set of matrices that satisfies this equation. Now, if I apply column interchange here, means if I apply, for example, this transformation C2 tends to C3, if I apply this, then what happens? These two columns gets interchanged, correct? Means this second column and this third column, they get interchanged, and then this system of equation doesn't come if you try to split this again, correct? Did you understand why we can't apply column transformations? Because if you apply column transformations, the given set of equations changes in this augmented matrix. Okay, clear? Did you all understand first of all why can't we apply column transformations? Because if you apply column transformations, then this coefficient changes, means the system of equation changes. So whatever we do, we can apply only for row transformations. I'll tell you. Okay, so now to convert this into row echelon form, we need to make these two elements zeros first of all, correct? So let us apply the transformation. R2 changes to R2 minus R1 and R3 changes to R3 minus R1. So if you apply this transformation, this implies A augmented B is equivalent to, first row doesn't get changed, so 1, 1, 1, then we have this, and 6, second row, R2 minus R1. So 1 minus 1, it's 0. Minus 1 minus 1, it's minus 2. 2 minus 1, 1. 5 minus 6, minus 1. Correct? If you apply for third row, 1 minus 1, 0. Minus 2 minus 1, minus 3. And 1 minus 1, it's 0. Again. Then 0 minus 6, this is minus 6. We got it here, correct? So actually you can interchange these two rows and you can make this element 0 because this is not in Euclidean format. If you see these two elements, these two rows, they have only 1 0 in the first before the first non-zero element. But for having Euclidean form, here if there is 1 0, definitely should have one more 0 here. But if you see, if you perform any transformation here, now let us try to make this element 0. But before doing that, let me try to do one thing. Since there is already 0 here, let us swap these two rows. Okay. So because if I don't swap, see what happens. Even though we can get the correct answer, but generally when there is 0 here, we generally swap the rows. If you want, you can perform without swapping also. R3 changes to 2R3 minus 3R2. So if you perform this transformation basically, so R3 changes to 2R3 minus 3R2, then this element here will be 0, correct? So then this implies A augmented B is same as first two rows doesn't change, 1 1 1 6 0 minus 2 1 minus 1. Now 2 times of R3 minus 3 times of R2, it's 0. 2 times of R3 minus 6 minus of minus 6, so minus 6 plus 6, this is 0. Next 2R3 minus 3R2, which is minus 3. This is what we have. Next here, if you see 2R3 means 2 into minus 6, minus 12, minus 3 into minus 1. So minus 12 plus 3, which is minus 9. So this is what you have generally, correct? So then if you compare this, augmentation matrix with respect to this system, we have x plus y plus z is equal to 6, minus 2y plus z is equal to minus 1, and minus 3z is equal to minus 9. For which you can solve easily now, correct? Because if you cancel the things, z is equal to 3. If you put z is equal to 3 here, you will get y is equal to 2. And if you put y is equal to 2 and z is equal to 3 in this equation, you will be getting 1. Okay, so by applying this Gauss elimination method, you can convert the given matrix into Euclidean form and you can work out the things in an easier way when compared to LU decomposition, which included more calculations actually. Okay, but this is of course a simple case. If you have some elements like 1 by 5, 2 by 4, and 2 by 3 and all these things, then even these calculations might have got a bit, complex. Okay, so this is how you will be identifying this Gauss elimination method. Now, the major drawback in this Gauss elimination method is first, when you are performing these transformations, with respect to this O1 and you are making these two elements 0. Now, for example, if there is 0 here, means in the leading diagonal places, if there is 0 here, in such cases, then what we'll do? Yeah, if you want, you can get the answer here as well, because you can write minus 3y is equal to minus 6 and all. But since my main point of interest is to convert to this, row transformation, Euclidean form, I have performed one more transformation. That's it. Okay, Vishnu, we'll interchange those in that case if this pivoting elements are 0. Okay, so as we discussed in LU decomposition case, if one of the principal diagonal elements of this upper triangular matrix is 0, then we'll swap the equations. Similarly, if you get a 0 here and all, we'll still swap the equations. Okay, so this is a Gauss elimination method, like how we performed this. Okay, now before going for one more method called Gauss siedel method, I would like to tell you one thing. A system of linear equations, a11x plus a12y plus a13z is equal to b1, a21x plus a22y plus a23z is equal to b2, and a31x plus a32y plus a33z is equal to b3. If this is the system of linear equations, then we call this system as diagonally dominant. The system of equations is said to be diagonally dominant. Is said to be diagonally dominant. Is said to be diagonally dominant if modulus of a11 is greater than or equal to modulus of a12 plus a13, individual moduluses, and modulus of a22 is greater than or equal to modulus of a21 plus a23, and modulus of a33 is greater than or equal to modulus of a31 plus modulus of a32. Means, by this time you might have understood what is diagonally dominant. Means this principal diagonal elements, if these are scalars such that in every equation, it means they are assigned to different variables in all the three equations. See, a11 is assigned as the coefficient to x. Similarly, here a22 is assigned as coefficient to y, and a33 to z. So here, this principal diagonal elements are assigned to different variables, and of course, they all are in such a way that they satisfy this condition. Then we say this system is diagonally dominant, and this is one of the necessary conditions for getting solutions to system of linear equations when we apply different iteration techniques like Gauss-Seidel method and all these things. Okay, so we'll see what's the use of this Gauss-Seidel method and all. Okay, so for that we will see Gauss-Seidel method. Gauss-Seidel method. Okay, now let us see what is this Gauss-Seidel method. Again, if a11x plus a12y plus a13z is equal to b1, a21x plus a22y plus a23z is equal to b2, and a31x plus a32y plus a33z is equal to b3 is diagonally dominant system. Is diagonally dominant system. Is diagonally dominant system. Then x r plus 1 is equal to 1 by a11 into, means basically if you write expression for a from this equation, you'll be getting 1 by a11 into b1 minus a12y minus a13z. Similarly, if you write expression for y from this equation, you will be getting 1 by a22 into b2 minus a21x minus a23z. Similarly, if you write another expression z from this third equation, z is equal to 1 by a33 into b3 minus a31x minus a32y. Okay, so if you see this x r plus 1 can be written as b1 minus a12 of y, the value that you obtain in the rth iteration, minus a13 into the value of z that you again obtain in the rth iteration, and y r plus 1 is equal to 1 by a22 into b2 minus a21 into x r plus 1 minus a23 into z in the rth iteration, and z r plus 1 is equal to 1 by a33 into b3 minus a31 into x r plus 1 iteration value minus a32 into z y r plus 1 iteration value. Okay, so means here we don't wait till all the variables are obtained. Means whatever the value, see for example you got x r plus 1, you will substitute it immediately. But in methods like Gauss-Jordan method and all, we don't substitute directly here, but we'll find all the values x1, y1, z1 for putting r here. Okay, so the main difference between Gauss-Jordan and Gauss-Seidel methods are Gauss-Jordan, of course I'm not going to discuss, it's very much similar to general iterative schemes, so I'm not discussing. But Gauss-Seidel, if you see, in Gauss elimination method, basically you'll be having something like this. Gauss, this thing. What do you say? Jordan method. 1 by a11 into b1 minus a12 of r minus a13 into z of r. Similarly, you will be getting y r plus 1 is equal to 1 by a22 into b2 minus a21 into x of r minus a23 into z of r. So basically, you will be calculating all x, y, z values with the initial guesses for the first step of iteration completely. Means you won't be using the updated values immediately in Gauss-Jordan. After finding all the set of unknowns, then you will go for next iteration where you will be using all this xr plus 1, yr plus 1, zr plus 1 and all. But here in Gauss seidel, whatever the value that is obtained, you will immediately use this in the next iteration. Okay, but whereas in Gauss-Jordan method, if you see 1 by a33 into b3 minus a31 xr minus a32 yr. This is how you will be calculating xr plus 1, yr plus 1, zr plus 1 and all. Okay, so here if you have some initial guesses like x0, y0, z0, we'll make some initial guess at random. So once if you make that initial guess, you will be getting x1, y1, z1 values in this Gauss-Jordan method in this first step of iteration. Again, using this x1, y1, z1 values, you will go for next iteration step where you will be getting x2, y2 and z2. But in Gauss seidel, we don't wait till the completion of the iteration step. Whatever the updated value that is obtained, we use it immediately and we will get the more convergence of the solution in a faster way in compared to Gauss seidel. Okay, but anyhow, questions on these two methods are not being asked for many years. But lastly, one question came in 2008 or 9, I guess. Okay, and I'm not sure whether they are in syllabus or not, but if they ask, you should know them. Okay, so I'm giving you this. So did you all understand the difference between Gauss elimination and Gauss-Jordan? This is for Gauss-Jordan. And this is for Gauss seidel. Okay, so in exam, if they don't mention anything, you should first of all convert the system into diagonally dominant. Means if the equations are swapped, you should swap them in a correct order such that this condition, this diagonally dominant condition, is held good. Okay, so but sometimes in exam, what they ask, apply Gauss seidel for the given set of equations in the same order. If they mention the word in the same order, just from the first equation get the value of x, from the second get y, from the third get z, and apply this iteration formulas for given initial guesses like x0, y0, z0. If they give some initial guess, you can calculate x1, y1, z1, and then iteration continues. But generally, if they don't mention, use Gauss seidel for the equations in the same order. If they don't mention this word same order, then first of all, the main thing you need to do is you need to convert this given system of equations into diagonally dominant system. Okay, so clear how to apply this Gauss seidel? Is that clear to all of you? Of course, we'll be making some initial guess here. x0, y0, z0 is initial guess. Then if you substitute y0 and z0, you will be getting x1 value. By putting x1, z0, you will be getting y2. By putting, y1, by putting x1, y1, you will be getting z1. Again, you will continue. And after certain number of iterations, the values of x doesn't change by much amount, and similarly by y and z. Okay. So this is how we'll apply Gauss seidel method for a given system of equations. And first of all, we'll see this diagonally dominance and all. Actually, frankly speaking, this numerical methods is a very vast discipline. Okay, it's not, to be honest, it's not possible to cover all the things within the range of us. But I am trying to give you the minimum idea regarding everything so that with basics you can work out the things. For example, if we talk about Gauss elimination, it would take some 10 lectures for us to discuss completely about Gauss elimination. There are things called pivoting, partial pivoting, and number of operations, different things. Okay, so but whatever is required for gate, I am teaching you that particular part. Okay, so I'm not teaching which is beyond the subject of gate, even though we are equipped with some knowledge regarding that. Okay, clear? So I hope you understood all these three methods: LU decomposition, Gauss elimination, and Gauss seidel. Okay, so now we'll start. Since time is so short for us, we'll start something called numerical integration. Numerical integration. Of course, we deal only quadrature formulas, and means basically like Simpson's 1/3, trapezoidal, and Simpson's 3/2. Okay, so only these three are in syllabus basically, so we'll deal with that. But we'll see some good points regarding all the methods individually. Okay, so basically, if there is some complex function for which the direct integration, integral a to b f of x dx, of course this function is continuous and differentiable, no issues. But if the equation of this curve y is equal to f of x is complicated generally, then we'll generally go for trapezoidal, numerical integration techniques, because substitution. Yes, in yesterday's class I told you one example. For example, if I have something like integral 0 to 4 x square into sine inverse x divided by log x to the base e into tan x and all these things, if you have, then it's practically difficult for us to evaluate this kind of integrals using this analytical methods, standard analytical methods, because we may not find proper substitutions and proper analytical ways. But now if you can, since if this is the equation of this curve, and if this is the points x is equal to a to x is equal to b, then geometrically that this is this area, correct? So if we can develop some technique to find this area geometrically, then this area is same as the value of this integral. So since both these are same, then this area and this integral can be are numerically equal, and evaluation of this integral is difficult. So it's better for us to evaluate what is this area. And all numerical integration techniques are based on the fact that this area, which is bounded by the curve, the lines x is equal to a, x is equal to b, and this x-axis, okay, means the area bounded by all these four curves basically. So we'll see the techniques straight away. So first of all, let me straight away start with trapezoidal rule. See, yesterday we lost 2 hours of class, but that happened really at the end. I'm so sorry for that. When syllabus is about to complete, and I just planned the things within 3 classes. 1 class of 2 hours actually has went off. Okay, so please try to manage the things within the given time. So trapezoidal rule. Okay, if f of x is continuous, if f of x is continuous in a comma b and differentiable as well, in a comma b, and if the interval is divided, and if the interval a to b is divided into n equal intervals, n equal subintervals, each of size h means subinterval size is h, means if the first interval is a comma a plus h. Okay, so this is first interval. Second interval will be a plus h to a plus 2h, and so on, things like this. Okay, then integral a to b f of x dx is equal to, can someone remember the formula and tell me here? Of course, I'll derive the formula, no issues. That's a simple thing to derive here. But do you have any basic idea? Like, what's the answer here? Okay, I have written this word 2 times. Okay, fine. 1 time we'll delete, no problem. Can you tell me any basic idea for this formula? No idea to anyone. Do you remember something? H by 2 into something, y naught, yn, y1, and all these things will come. Do you remember this at least? How many of you remember that? There will be something like 1 divided by b minus a and something. No idea, sir. Yes. Okay, no problem. We'll get idea now. Okay. So we'll see what's the formula that will come here. Okay. See. 0, x, y, and for example, something like this, some random curve, y is equal to f of x. Okay. Now, h by 2 into y naught plus yn plus 2 into y1 plus y2 plus and so on plus yn. Good, Usha. I think you have some memory which is not available for all of us. So see here. We'll see. Now, this value is x is equal to a. This value is x is equal to b. Okay. Now, okay, Subramaniam, you are also writing the formula. But that's not xn's, it's yns actually. Okay. So see here, anything, we'll see what's the story. Now, this value integral a to b f of x dx is same as this area bounded, correct? So first of all, what we are doing, we are splitting this a comma b interval into n subintervals. Means if you are writing this, then this is x is equal to a plus h. And if you split one more, this is x is equal to a plus 2h. And finally, this goes on after some finite number of steps. This b is equal to a plus nh. Correct? B value will be equal to a plus n into h. Let me write this. X is equal to b, which is a plus nh. This is what we'll have. Correct? Because the end of this first interval, the value of x is a plus h. In the value of this, the value of x by the time of second ending of interval is a plus 2h. So if this is the nth interval, means if you are dividing this a comma b into n subintervals, then this is the nth interval, and the value of b will be a plus nh. From this, we can deduce one thing: b minus a divided by n is equal to h. And it's obvious, if you are dividing the length between a and b into n parts, length of each part is b minus a by n. Now, the important thing is, see, we want this complete area. Correct? Now, let us first of all try to draw this first block. Okay, so first block I am drawing here. So please see carefully. A plus h, and this is some curve that's connecting something like this. Fine. Okay, or else maybe let me show you some curvature as well. So something like this. Okay, so this. Now let us suppose this value is x0 and x1, x2, x3 and so on xn. So let me call this as y0. Means this value is y0 basically, and this value is y1 and so on. Finally, you will be getting somewhere yn. This height is yn. Okay, because this is f of xn. Means if I am writing this as x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h and so on. See here, this is xn. Correct? This is what we have. Now, if this is x0, then this value is f of x0, because this curve is y is equal to f of x. So if this is x0, this value is f of x0, and let us call it as y0. So this value is y0 and y1. Correct? Now, actually, if I do one thing, see carefully. If I calculate this area for this block, similarly, if I calculate area for each and every individual block, and if I add all those things, will I get the total area again? Please say yes or no, because for other two things, I would like to give expressions. So I'm dealing this in a explanatory way. So please tell me, if I find the area of this, and if I find area of all these individual elements, and if I add together, will I get the total area of this curve? So if we get this, see carefully. But practically finding when there is curve is much difficult for us. So the one assumption that we do here is, if this is point A and if this is point B, connect these two with a straight line. Connect these two with a straight line. Then if you see, the small change in the value of this area is negligible, correct, when compared to the total area. Because if this h size is sufficiently small, then this h will be very small, and this small portion of area that is left over between this yellow and green color curves is negligible when compared to the total area. Did you understand? By making this straight line assumption, the answer doesn't change much. Will you agree with this, all of you? By connecting these 2 points with a straight line, the area what we calculate for this trapezium is almost equal to the area of this first block, because the change in the value is very small, which is unhatched and not hatched here. Did you all understand? Connecting these two by a straight line couldn't change the answer by much. Will you all agree with me? If h is sufficiently small, because for small values the convergence, the curvature is very less. Correct? Did you all understand this? So now, if you see, if I call this as CD, for example, point CD, then you see this curve ABCD. What is this called? ABCD, out of which one pair of lines are parallel and another pair is not parallel. Please tell me, what is this figure called? It is called trapezium, correct? And that's why this name trapezoidal rule came. Now, if you want to calculate the area of this, if I call this as A1, for example, A1, A2, and so on, AN is the area of the nth block. Okay. So now, if I want to calculate this area of the trapezium, this length is Y0, this length is Y1, and the distance between the parallel sides, this is nothing but step size, which is H. So what's the area of this triangle? I mean, of this trapezium? This area A1 is equal to half into H of Y0 plus Y1. Correct? Because you know, area of the trapezium is half into distance between the parallel sides into sum of the parallel sides. Correct? So half H into Y0 plus Y1. So let us add it here. H by 2 into Y0 plus Y1. Okay. And this is Yn minus 1, of course. If that is Yn, then this height, which is this, will be Yn minus 1. Okay. So this is area of the first part. Now, what could be the area of the second trapezium? Means this, if I again connect these 2 points with a straight line. Please tell me what could be the area of the second part. Again, if I connect these 2 points with a straight line. All of you. Around some 48 are on live. So please tell me what could be the area of the second trapezium. If this is Y1, this is Y2, and so on, Yn minus 1, Yn and all. So please tell me what could be the area of this trapezium? H by 2 into Y1 plus Y2. Correct? Because Y1 is the parallel side, Y2 is the next parallel side, and the distance is again H, because we are assuming uniform step size H. So if you see, area of second trapezium is H by 2 into Y1 plus Y2 plus. Similarly, area of the third trapezium will be H by 2 into Y2 plus Y3, and so on. The area of this last trapezium, when these two are connected by a straight line, is given by H by 2 into Yn minus 1 plus Yn. Correct? Yes. So this sequence goes on. Now, if you see carefully, in every term there is one H by 2. Correct? So let us take that H by 2 common first of all. Okay. So let us take one H by 2 common. Now, if you see this Y1, which is the last term of the first, the last term in the first part, is again coming here, and this Y2 here is again coming here. Y3 here will again come in the next term. Similarly, this Yn minus 1, which is here, will also come as the second term in the previous n minus 1 term. So if you see, except this Y0 and Yn, every other term is coming 2 times within this expression. Correct? Did you all understand this? Apart from this Y0 and Yn, every other term, Y1 appears 2 times, Y2 appears 2 times, again Y3 appears 2 times, and so on. Excluding this Y0 and Yn, every term appears twice in this equation, in this expression basically. Correct? So let us write this Y0 plus Yn plus, we know every other term comes 2 times within the equation. So if you see, 2 times of Y1 plus Y2 plus Y3 and so on plus Yn minus 1. And this is the formula that we are struggling to write before. And there is nothing much difficulty in this. So we can write integral a to b f of x dx is equal to h by 2 into y0 plus yn and all these things. Okay, so this is the formula for trapezoidal rule, and since we are connecting these 2 points by a straight line and it's forming a trapezium geometrically, that's why the name of this is given as trapezoidal rule. Okay, clear to all of you? Did you all understand how this expression came? Now in exam, if you forget this formula, if you remember this basic that we need to form trapeziums, you will get this formula correctly. Okay, no need to remember this now. Okay, it's clear. Yes, so see here, we'll talk few good things about this. How can we get y0, y1, y2? In exam, they'll give you. Okay. If they don't give you, if they give you function, you can calculate. We have some examples, we'll solve how to get this y0, y1, y2 and all these values. Okay. So now if you see, for h is equal to, see here, for h is equal to b minus a by n, we got integral a to b f of x dx is equal to h by 2 into y0 plus yn plus 2 times of y1 plus y2 and so on plus yn minus 1. Okay, now if you see few things clearly, these 2 points are fitted by linear equation. Correct? Means linear equation means a polynomial. If you take this equation, means this curve with which you are connecting y is equal to g of x, for example. If you are taking this y is equal to g of x as the polynomial with which you are fitting these 2 points, what is the order of fitting polynomial here? What's the order of linear equation? Degree of linear equation? 1. Correct? So if you see, the order of the fitting polynomial that we are fitting here to join these 2 points is 1. And that's why we say, first point, the order of fitting polynomial, the order of fitting polynomial in trapezoidal load, the order of fitting polynomial in trapezoidal load is how much? All of you, please respond. Around some 55, 56 are on live. So please respond. How many? What's the order of this fitting polynomial? So if you see this curve, we are fitting these 2 points by a linear approximation, means with a straight line. So the order of the fitting polynomial is 1. And this is a gate question in 1 year. Okay. So next, the error between analytical and approximate value between, okay, let us say the error between actual value and approximate value, sentence could be more appropriate, between actual and approximated value evaluated, approximated value that is evaluated using trapezoidal load, yes, means generally if you have an integration with a given integrand f of x and limits a to b, you can calculate the integration analytically, but also you can evaluate the integral using trapezoidal load. And you know, numerical iterations generally give the approximate values but not the exact values, so there will be some change as we talked yesterday in the beginning of this chapter. So this error is equal to b minus a into h square divided by 12 into modulus of maximum of f double dash of x in a comma b. Okay, so b minus a, b is known, a is known to you, h is known to you, 12 is a constant, and if there is a function f of x, you know how to find f double dash of x and find the maximum value of this f double dash of x in this interval in a comma b. Okay, so if you can write this, then we can say one thing. Third, if the order of f of x is 0 or 1, means basically this f of x, if it's a constant function or if it's a linear function, means if it's of order 0 or of order 1, then the value obtained by the value of integral a to b f of x dx obtained by trapezoidal load and analytical method. Trapezoidal load and analytical method is same. So is same in the sense that error is 0. Can you tell me why? If f of x is either a constant function or a linear function, can you tell me why these values are same, means why this change is 0? Because can you tell me, any one of you, can you think? I gave you the result, can you give me explanation for this third point, why it should happen? Straight lines. And one more thing, correct, Vijay, geometrical if you say straight lines, mathematical if you see, I wrote into maximum of f double dash of x, correct? Yeah, differentiation is 0. So if you see, if this function is at maximum first order function, means if f of x is a linear function, for any linear function y is equal to ax plus b, is equal to f of x. What could be f double dash of x? Please tell me. For this function, what could be f double dash of x? If f of x is ax plus b means linear function, what could be f double dash of x? 0 means if you differentiate any function more times than the degree of this function, then what happens? Of course, for polynomial functions we are talking. So if you see, if you differentiate any function more number of times than the degree of the polynomial, then answer is 0. So if you see, this value is 0 because maximum of 0 in a into b, and 0 multiplied to this will give you 0. This is what mathematically, fitting polynomial is this polynomial which you are fitting between the 2 points to calculate the area. Here I am fitting a line segment. Okay, so this is called fitting polynomial, child. Okay, and now practically speaking, if f of x is constant or linear function, then what happens to this line? This curvature won't be there. It could be the case like this, or it could be the case like something like this, or maybe like this. So if you split this interval, then if you connect these 2 points by straight line, again these two curves are same. It's already a straight line, and again the fitting polynomial is also a straight line. So there won't be any change within the areas, and we form an exact trapeziums in each and every case. So there won't be any this region which is between yellow and this white in these cases, in any of these 3 cases. Okay, so which means the analytical integration will also give you the same answer as we have evaluated using this trapezoidal method. Okay. Next, let me shorten this a bit. So we'll write 2-3 points here, 1 point here. Okay, next, 4th point. The order of error in trapezoidal rule. Trapezoidal rule is, you can see what is the order of, can you say what's the error? It's of order h square. Okay, because you can see there is h square in the term, so h is the step size, and apart from this all these are fixed. F of x, a comma b, a b are fixed, 12 is a fixed. So the only choice that we left with is to make the choice of this h, means depending on number of intervals. As number of intervals increases, your accuracy increases, means change decreases. But of course it consumes some time, more time. So we'll make a decision to make a proper choice of this h, means basically since h is equal to b minus a by n, we'll make a suitable choice depending upon our physical applications to decide this value of n. So this h is the only value which is in our hands. But apart from this h, this f of x, a, b, all are defined in the question already. So we can say this error is of order h square, and if you are choosing less number of intervals, then this h increases and this h square increases. So this total change increases. It's obvious. If we divide this into less number of intervals, then what happens? This change increases. Correct? This is how we can write some good points about trapezoidal rule. Okay, so did you all understand all these 4 points which I have written here? So please tell me, did you all understand what is trapezoidal rule? Okay, since the fitting polynomial is linear, we call the order of the fitting polynomial is 1. Okay, so next we'll go for something called Simpson's 1/3 rule. Simpson's 1/3 rule. Okay, so see here. Again, same story. If f of x is continuous, in a comma b and differentiable in a comma b, then and if the interval a to b is divided into n equal subintervals, n equal subintervals. Of course, this n is even in this case. I'll tell you why n should be even. No, don't worry. But please remember, if you want to apply Simpson's one-third rule, you need to split the complete interval that's available to you into equal number of even number of intervals. Okay, so some subintervals, then integral a to b f of x dx is equal to, we'll write the formula here. So see, why to consider this even number of intervals? That's the main question. So see here, 0 x f of x is equal to y, of course. And let us suppose you got some curve, again some random curve, which is y is equal to f of x. Okay, so next, now if this is x is equal to a, x naught is equal to a, for example, and this is xn, which is b. Of course, let me write this x here, and b is equal to a plus n times of h, if you are dividing this into n subintervals. Correct? And of course, n value is even. Oh, you're already up with the formulas already. H by 3 into y naught plus yn plus 2 times of y2 plus y4 and so on, plus 4 times of y1 plus y3 and so on. Okay, so let me see whatever we get. To be honest, I don't remember that, but we'll write this. Okay, so this is x1 is equal to a plus h, but in exam it's mandatory that we remember this, otherwise it takes us some time to calculate again. Okay, so a plus 2h and so on. Of course, finally you will be having xn minus 1 is equal to a plus n minus 1 into h, and this is xn minus 2, which is a plus n minus 2 into h. Okay, so this is what we have. Now, the main thing that we do in Simpson's one-third rule is, let us take these two intervals here, some random curve, which I am not bothering right now. Okay, so this is x naught, which is a. This is x1, a plus h. This is x2, a plus 2h. Okay, so in Simpson's one-third rule, what we do is, we consider a pair of intervals at the same time, and we'll fit them with a, quadratic curve. Okay, we are fitting this with a quadratic curve, because when h is very small, the area which we lost here will get compensated here. Means if you see, if you calculate the area under this yellow curve, this part of the actual area is lost, but for the area that we lost, we have a compensation on the right hand side. Some excess part will get added, and of course this is more accurate than when compared to linear approximation. Correct? Of course, because if you consider linear approximation, some part of the areas are lost and all, but if you are making some quadratic this thing, then analysis could be much more accurate. So if this is a quadratic curve, the equation is of the form a naught plus a1x plus a2x square. Okay, so this, if you see, this as y naught, y1 and y2. Then we will calculate this area under this yellow curve. This complete area we will calculate. Okay, so now if you take this as a plus h, and this as a plus 2h, now one thing, integral this function from x0 to x2. Let me write it here. We'll write this formula later, so let me write it here. Integral x0 to x2, a0 plus a1x plus a2x square dx is the actual area for this. Correct? This area is the actual area that represents the shaded part, means the area under the yellow curve. Correct? Now this area, if you make calculations, I'm not making because of time constraint, purely because of time constraint, I'm not making this. But if you make calculations for this, and if you equate, you'll be getting something like h by 4 into, where h is the step size, y0 plus 4 times of y1 plus y2. This is what you'll get. If you equate this, if you calculate this area, means with the limits from a to a plus 2h, if you calculate this limits from a to a plus 2h, then this integration value will be same as this value, which I'm not going, but you can try if you want. If you have some time after the class, you can try, but right now I'm not tying it. So this value, if you're running from a to a plus 2h, a plus 2h. So if you perform this value integration, you will be getting something like this. Okay, and the fitting is quadratic because as the high degree of the fitting polynomial increases, the accuracy increases. So compared to this linear polynomial, if you are fitting a quadratic polynomial, your accuracy or the answer will converge to a better value. So now if you calculate, if you compare this 2n times of intervals all the time, see what happens. Did you all understand this part, what I told you? For this part, for this first two subintervals, did you all understand till this point? This Simpson's one third rule? Please say yes or no. There are some 50 something, 51 are on live. So please tell me, did you all understand this? Okay. So now, if this area is h by 4 into y0 plus 4y1 plus y2, what would be next two parts? Means if I take y2, y3, y4, next again, these two subintervals, if I take y2, y3, y4, what could be next area? Means if this is a1, if this complete part, if I'm calling this as, a1, what could be next part? A2, h by 4 into, sorry, this is not h by 4, this is h by 3 actually. Okay, please make this correction. This is h by 3. Okay, it will be h by 3 if you make the calculations. So if this is h by 3 into y0 plus 4y1 plus y2, then please tell me what could be the next part of the area. Means if I'm considering a plus 2h, a plus 3h and a plus 4h, and if I calculate this value, tell me what could be this value for the next part. I want responses, please respond. Okay, if I'm applying this for the next part by considering next two intervals where we have y2, y3, y4, please tell me what we'll be getting here for a2. So let me write the equation first. Integral a to b f of x dx is equal to h by 3 into y0 plus 4y1 plus y2. This is area of the first two subintervals, plus next for next subintervals h by 3 into y1 plus 4y2 plus y3. Sorry, y2, y3, y4, because we are considering 2, 3, 4 as next points. Okay, so this is what we have: 2 times plus 4y3 plus y4 into h by 3, and so on. This goes on till h by 3 into, for the last set of intervals, yn minus 2 plus 4 times of yn minus 1 plus yn. This is what we'll be getting as the expression. Correct? So now if you see the things clearly, this h by 3 can be taken out. This y0 and yn will be repeating only once. I mean, they occur only once. So y0 plus yn will be occurring only once, plus if you look at odd subscripts, means 1, 3, 5 and n minus 1 and all, if you look at odd subscripts, you will be getting 4 times of each value. So 4 times of y1 plus y3 and so on plus yn minus 1, and 2 times of every ending value. Y2 here, again it's here. Y4 here, and again it will be here. Similarly, this yn minus 2 which is here will also appear in the previous step. So if you see y2 plus y4 and so on plus yn minus 2. This is what you have for the integration formula. Integral a to b f of x dx. Which if you want, you can put it under a box. So did you all understand how did I achieve this formula? It's purely based on geometry that we are assuming here. Okay. Clear? Did you all understand this? Why I have written this way? Please tell me, did you all understand this? Why this trapezoidal rule formula is this? 4 times of something and plus 2 times of some other things. Okay. So now we'll summarize the results again. First result. The formula or the integration formula of Simpson's 1/3 rule. Simpson's 1/3 rule. It's already 8:40. Okay. Simpson's 1/3 rule is integral a to b f of x dx, which is equal to, now tell me, yeah, we are considering 2 parts at a time, Yugandhar. Okay, so we are taking 2 subintervals at a time, and we are fitting a quadratic polynomial for these 2 subintervals simultaneously. Okay, so h by 3 into y0 plus yn plus 4 times of y1 plus y2 and so on, plus what do we say, this yn minus 1 plus 2 times of y2 plus y4 and so on, plus how much, this yn minus 2. This is what you have. Next, second part. The order of the fitting polynomial y2 should not be there. Actually here it's y3, correct? Okay, sorry, it's a typing mistake, I mean sorry, a writing mistake. So see here, the order of the fitting polynomial, okay, the order of the fitting polynomial in Simpson's 1/3 rule, is how much? All of you please respond. The order of the fitting polynomial in Simpson's 1/3 rule is how much? All of you, how much? With what degree polynomial we fitted here? It's a second degree fitting polynomial, correct? So this is 2. Next, the error between actual value and actual value means how you will evaluate this. Sorry. Actual value means how you will evaluate this using analytical method. And approximate value. And how you are evaluating this approximate value? How you are evaluating this approximate value? Using Simpson's 1/3 rule. Using Simpson's 1/3 rule is how much? Is b minus a into h power 4 divided by 180 into modulus of maximum of f fourth derivative of x in a comma b. Okay, this is fourth derivative. Generally first derivative, second derivative, double dash of x, triple dash of x, and fourth derivative of x. So if you know f of x, you can calculate fourth derivative of x in a comma b. So with this, we can say the order of error in, okay, right? Better, the change in trapezoidal, Simpson's 1/3 rule. Simpson's 1/3 rule is of order of h power 4. Okay, because we see h power 4 term there, and which is only the thing that we can decide. Apart from h, everything is decided in the problem. So this is what we have here for Simpson's 1/3 rule. Okay, clear about Simpson's 1/3 rule to all of you? Actually, during your free time, you can check this. This is the value which you will be getting if you calculate this. Okay, but because of time constraint that we have, I'm not doing it here. Okay. So did all of you understand this Simpson's one third rule? So we'll be able to apply. We'll see one more rule, Simpson's 3/8 rule, before going for problems, because it's 8:45 and we have only 30 minutes. So numerical differential equations I'll deal tomorrow. Okay. Monica, okay. We'll see whether we can complete or not. This question is coming already. Okay. So for Simpson's one third rule, I'll just give you the idea and I'll write the formulas. Okay. So please see here. Simpson's 3/8 rule. Again, I write the same story. If f of x is continuous and continuous in a comma b, in a comma b and differentiable in a comma b. Okay, if f of x is continuous here and differentiable, and the interval a to b is divided into n subintervals of same size each, or you can write n subintervals of equal size. In brackets, you can write n is a multiple of 3. N is a multiple of 3. Okay, so if you want to apply Simpson's 3/8 rule, you need to apply, you need to basically write this 3 times, divide this interval into multiples of 3 subintervals. Okay, then integral a to b f of x dx is equal to, I'm writing the formula, but I would like to give you the geometrical idea just how these are evaluated. 0, x, y, and some random curve y is equal to f of x, of course, which is continuous and differentiable always. So now, if this is x is equal to a, if this is x is equal to b, and if you are splitting this into n intervals, this is a plus h, basically x1, x0, and this is x2 is equal to a plus 2h, and this is x3 is equal to a plus 3h. Similarly, from the last, if you split, this is yn minus 1, yn minus 2, and this is yn minus 3. Of course, these are x, y0, y1, y2, y3, and so on. Similarly, yn, and this goes on like this. Okay, so now in Simpson's 3/8 rule, what we do is we consider 3 intervals at a time. We consider 3 intervals at a time. For which the actual curve is something like this, and these values are a plus h, this is a plus 2h, and this value is a plus 3h. So if you have this, so this area, if you fit with a cubic polynomial, okay, so this is cubic polynomial with which we fit in general. Cubic polynomial, which is of the form a0 plus a1x plus a2x square plus a3x cube. And we'll find the area of this part, which is under this. So as the degree of the polynomial increases, the accuracy increases. So we'll calculate this area, and finally, if you sum up all these areas by taking 3 subintervals at a time, similarly here, you will be getting the expression something like, 3h by 8 into y0 plus yn plus 3 times of y1 plus y4 plus y5. Sorry, here we have y2, then y4, y5, and so on, plus yn minus 1 plus 2 times of y3 plus y6 plus y9 and so on, plus yn minus 3. This is the Simpson's 3/8 rule formula that we obtain for calculating these integrations in 3/8 rule by assuming a cubic polynomial fitting, and the answer increases. Okay, so now in exam, if they don't mention 1/3 or 3/8, you can by default take 3/8 rule. Okay, just this 1/3 and 3/8 are just given by the variation in these coefficients. Here it's 3/8 and here 1/3. Okay, both are given by Simpsons. They have identified by these constants, which is with multiplication of h. Okay, so 3/8 is this value which comes here, and that's why it's called 3/8 rule. Means 3/8 of this complete value, h into this complete value. Okay, and also 1/3 into the complete value in 1/3 rule. So in exam, if they don't mention you either 1/3 or 3/8 rule, go for 1/3. Okay, because this in this calculations are a bit more when compared to 1/3. Okay, so now this is the formula. Of course, I'm not deriving it. If you want, you can see integral a to a plus 3h. If you calculate, you will be getting something like 3h by 8 into y0 plus 3y1 plus y2 plus 2 into y3. This is what you will be getting for first term. So how is the polynomial considered? Like, won't we get coefficients? See, y0 and yn are nothing but the coefficients only, Monica, because see, this y0 is nothing but this f of a. Similarly, this y1 is nothing but f of a plus h. So if you see, these points where we are trying to match this are again the points on the polynomial as well. Okay, so the values we'll get in terms of these coefficients, and the values which are in these coefficients will get converted to again y0, y1, all these values. Okay, so actually we'll be getting the answers in a0, a1, a2 and all these things, but we'll convert these coefficients into this y0, y1 depending upon these points which are lying on this curve. Okay, so see here, we'll see some salient points about Simpson's 1/3 rule also. The integration formula in Simpson's 3/8 rule. Simpson's 3/8 rule is integral a to b. Of course, you know the meanings. What is a, what is b, what is f of x and all. So I'm not writing them again. So y0 plus yn plus 2 times, plus 3 times of y1 plus y2 plus y4 plus y5 and so on. Finally, we'll go to yn minus 2 plus yn minus 1 plus 2 times of y3 plus y6 and so on plus yn minus 3. Okay, now second point, the order of the fitting polynomial. The order of the fitting polynomial. The order of the fitting polynomial in Simpson's 1/3 rule. How much is it? I mean, in Simpson's 3/8 rule. In Simpson's 3/8 rule is how much? All of you, please tell me. How much is the order of the fitting polynomial that we are fitting? We are fitting a cubic polynomial, correct? So this is 3. Next, the error between the actual value and value obtained by Simpson's T8. Simpson's T/8 is equal to, means basically the change between these two values is T/80 into h power 5 into maximum of fourth derivative of this x, f of x in a comma b. So you can see the order is of order, I mean the change is of order of h power 5, and it's obvious as the degree of the fitting polynomial increases, you know, this change decreases. So when h is less than 1, h power 5 will be very much less when compared to h power 4. So which means the change is less, which means the values are accurate to each other. Okay. So we have some 20 minutes left, not even 20, some 18 minutes left. We'll solve some questions on them. Okay. Trapezoidal with the knowledge that we learned so far. Okay. I have seen many notebooks, standard notebooks, you know, even I don't want to mention the names of the people and all, but they generally know only this formula. They'll just tell you that. But we have previous gate questions which can't be answered only if you know this formula. Okay. Not only this Simpson's 1/3, trapezoidal. If you know only formulas, you know, things won't get settled in exam if there comes a question beyond that. Okay. So clear to all of you? Did you all understand all these three methods of this numerical integration in a good way? Please tell me yes or no. Did you all understand them? If you understand, we'll start solving questions. If you have some doubt at any point, we'll rediscuss the things. Okay. Okay. So we are going. This is the first question. Abhinandan, where are you from? Tamil Nadu or Chennai? Delhi. Okay, good. Normally that N ends for Tamil Nadu people. Okay. With respect to polynomials, there is no difference, but with respect to differential equations, we have some difference between them. Okay, Chen. So the order is basically depend upon what's the, you know, degree of this h in the changes. Okay, there are formulas for this. There are derivations for each of this. Yeah, but I'm not dealing it right now. But this order of h power 5 is this h power 5 which is here. Okay. Similarly, if you go for Simpson's 1/3, order of h power 4 is h power 4 here. Clear to all of you? So please try to answer this question with the knowledge that we have. A, option A, Subramaniam. 1 exactly. Okay, let me check. So the integral 1 to 3 1 by x dx when evaluated by using Simpson's 1/3 rule on two equal subintervals means this interval 1 to 3 is divided into two subintervals. Two subintervals means if you take h value, h is equal to b minus a by n. So this implies h is equal to 3 minus 1 divided by 2. So the answer is 1. So step size is 1. So when if you take initial value as x0, y0, or let us write this x and y. Initial x0 value is 1. So for 1, next 2, and then 3. So which means this is how we are splitting this interval 1 to 3 in two subintervals because we got a step size 1. So if first x0 is 1, then next x1 is equal to a plus h, which is a plus h2. The second value is a plus 2h, and the interval got ended. And this n is already given in the question, two subintervals. Okay. So now y is equal to 1 by x. So now let us calculate this. 1 by 1, 1 by 2, and 1 by 3. So we have here. Now we got x0 values and we got x0, y0, x1, y1, x2, y2, and all these things. So let us apply the Simpson's 1/3 rule. So Simpson's 1/3 rule implies integral 1 to 3 1 by x dx is equal to, you know, h by 3, h is 1. So 1 by 3 into y0 plus yn. 1 plus 1 by 3 plus 4 times of y1 1 by 2 plus 2 times of y2 and all not there because this y0 and yn are already utilized here. See, one very important thing in applying this integration techniques is the values which are already considered once, they should not be considered again. Okay, it's not like since this is y0, y1, y2, I write plus 2 into y2 again because this yn is already taken here. Okay, so see 1 by 3 into 4 by 3 plus 4 by 2, 4 by 3 plus 4 by 2. Of course 4 by 2 is 2, so you can cancel this again, no issue of writing like this. Then 1 by 3 into if you take LCM and all 10 by 3, so 10 by 9. I hope the answer is 1.111. Option C. Okay, see, during my lectures you can ask anything. Yeah, 4 times of what? That's what I have written here, y0 plus y1 plus 4 times of y1, but there is nothing to write plus 2 times of even terms. Okay, because this even term, which is this 1 by 3, is already considered here as the final term, y0 plus yn. Okay, that's what I told you. Values which are once already considered, they should not be reconsidered even if they are lying in the even or odd conditions. Okay, clear to all of you? Okay, so is that fine? Can we move ahead? See, in my class, you can ask me whatever the doubts you have. Okay, it's not like I will, look you in a down way if you ask something which is basics. I am happy to say all the things at any time. Okay, so we are moving for the next question. I hope this is a simple question. Intervals is given. Interval AB is given. Number of subintervals is given, so you can calculate the things easily. So then we got one question. Match the following. This is a previous gate question actually. So you should know what is order of fitting polynomial. So Simpson's 3 by 8, so match them. Match them first. Option D. Now you are very fast to answer this, correct? Because we know Simpson's 3 by 8 rule, we fit a third order polynomial. So P should go to 3. Means these two are wrong options. Next, trapezoidal rule, we fit with a linear polynomial. So Q should be 1, which is not here, but it's here. And of course, R should be 2. You know what? Once when I was teaching in Chennai for this particular question, I have a little story which I would like to share for 1 minute. Okay, there's a student. He attended this trapezoidal rule formula and then he went for break. By the time he came back, I was discussing this question. He told the correct answer. Then I asked him how. The answer he told was, sir, first you taught trapezoidal rule, next you taught Simpson's 1/3 rule, and next you taught 3 by 8 rule. So the order is 1, 2, 3. Okay, which is first thing I taught him is trapezoidal rule. So second thing I taught him is Simpson's 1/3, and third method I taught him is Simpson's 3 by 8. So that's how he confirmed the order of this is 1, 2, 3 for these 3 methods. Okay, but which is not actually the case there. So please don't do such kind of things. Have the things in a good way. Okay, once in IIT JEE class, I was teaching for IIT JEE 2 years back. So the question I gave them was, what is the answer for this? Limit x tends to 8 plus 1 by x minus 8. What's the answer of this limit? Eight plus positive infinity, correct? This is what I wrote. And then I gave them another question, limit x tends to 5 plus 1 by x minus 5. For this also answer is infinity, correct? Because both the things follow the same case. Limit x tends to a plus 1 by x minus a is infinity. But there is one particular student at class 11 level who is very intellectual. He thought this symbol is the 90 degrees rotation of 8. And he answered this as something like this. Okay, these are the things happened that when I was teaching this school kids and +2 IIT JEE actually. So this is what it happened. Okay, he answered this in a reverse way. He thought that this infinity, he don't know basically what is this infinity, and he tilted this 8 by 90 degrees and he assumed this. So he tilted this by 5 by 90 degrees and he gave here. Okay, but of course he is a class 11 kid, so not much issues with him. So see here, we'll go. Okay, but don't make such kind of things. Your actual answer is this Simpson's 1/3 is a second degree fitting polynomial. This is the answers. Okay, so we'll go for next question quickly. So see this question. It's a very lengthy question, I think, but its answer is simple. So please try to solve this question and tell me the answer, all of you. The integral x1 to x2 x square dx with x2 greater than x1 greater than 0 means basically is telling both this x1 and x2 are positive values of x, means they are more than 0 basically. Is evaluated analytically as well as numerically using a single application of trapezoidal rule. Single application means he did not divide it into subintervals. For the interval what is available, he directly applied trapezoidal rule, taking y0 and y1 as the initial and final points. That's it. So he did not divide this interval x1 to x2 into subintervals again. He directly gave this. Yeah, in 1/3 rule, division should be even. Correct. So no. In Simpson's 1/3 rule, we should have even number of subintervals. That's why I told you here. If you see, if you quickly recall the things that we discussed. Okay. So if you see here, for Simpson's 1/3 rule, I told you n is even here. Okay, so for Simpson's 1/3 rule, you should have even this thing. Okay, so see here the integral x1 to x2. So many of you answered it's option B. Someone answered it's D. Okay, see actually what's the correct answer, I'll let you know. Look, this is 0, x, y is equal to f of x. Now how does the curve y is equal to x square looks as? Option D, data is insufficient. Okay, let me check, let me see whether data is insufficient or sufficient. Now the curve is y is equal to x square. You know the curve y is equal to x square looks something like this. Correct? Y is equal to x square. Now this 0, I mean x2 greater than x1 greater than 0. So means this x1 and x2 both are positive. So let me check. Let us suppose this is x1 and somewhere here this is x2. Okay, so x2 is greater than x1 and both of them are positive actually. So now see carefully. Okay, if I is the exact value of the integral, what is the exact value of the integral? If these are the points, then you know this area is the exact value of the integral. Correct? This value is the exact value of the integral. But now if you apply trapezoidal rule, then what happens? In trapezoidal rule, what do? You join these 2 points with the help of a straight line. Correct? So if you are joining these 2 points with the help of a straight line, something like this. So geometrically, you should know all these things. Okay, only then you can answer this question. So if you are applying trapezoidal rule, then we are fitting these 2 with a straight line, and the area of this trapezium is something like this. Now it's given trapezoidal value is how much, means the value that you got when you evaluated using trapezoidal rule is how much? J, and analytical value or exact value, this is how much? I. Now if you understand this much, please tell me out of these 2 areas which area will be more, the yellow shaded part or the green shaded part? Tell me in terms of colors, out of these 2 shaded parts, which area will be more, yellow shaded part or green shaded part? Yellow shaded part. Correct? Which means the area which you evaluated by making this trapezoidal assumption is more. Correct? And if you see, this trapezoidally evaluated value is J, and J is greater than I, which you can see geometrically here. Okay, now if you know this formula h/2 into y0 plus yn and all, you can't solve this question. And this is a previous gate question actually. Okay, so clear to all of you? And if you see, they have also given insufficient data to determine the relationship, because if you know only that formula, you don't know what is this x1 and x2, so you'll go for option D. That's the intention of them. Okay. Okay, so see here. Here, one thing we'll make, rather than putting 0 here, we'll put 1. Okay, better. 1 is somewhere here. Sorry, I think this should be 0 and this is 0 and x2 less than 1. We'll make one more assumption, x2 is less than 1 for this. Okay, because if x2 is greater than 1, then when connecting this interchanges, so x2 is less than 1 in this case. Okay, so see here, normally the area under this white line which I have drawn here is the area, exact area of this integration from x1 to x2 x square dx. Now if I am joining these 2 points with a straight line, then this yellow line is the curve which encloses the area. So if you see, the area under this yellow curve is more than the area under this next curve. Then we can't decide, because for 0 to 1, this x square curve like something like this, and this is 1. I mean, y is equal to x square is something like this, and this straight line will be something like this in this case. But if it crosses, then see, one thing I want to tell you, basically there is no necessity of this x2 to be greater than 1 also, because I'll tell you why. See here, there is no necessity of that. In any case, this will be how, because this line need not be y is equal to x. Okay, I'm telling you, many of you are feeling that this line is y is equal to x. No, there is no necessity. It's just a line that connects these 2 points. This line need not pass through origin. Okay, normally that what we are discussing is for y is equal to x and y is equal to x square. Yes, then your answers changes. But this line here is not y is equal to x. Okay, it's just a line that's connecting these 2 points. This line need not pass through origin. Correct? Because this general equation is y is equal to ax plus b, and it's not mandatory that this b should be 0. Clear? So in any case, this will be the answer. That's it. Okay. If y square is equal to x, yes, then things changes and j will be less than I in that case. Okay. For thermodynamics, tomorrow is the last class. Okay. So see here, we'll talk about this. So did you all understand how that j is less than I? I mean greater than I in this case. This line need not be y is equal to x. Okay. It's just the line segments that's connecting these 2 points. Clear to all of you? So in any case, j is greater than I as long as that it's positive. Again, the x2 less than 1 is not needed, because this line is not y is equal to x. Okay, this is some random line which is connecting these 2 points a and b. Okay, there is no necessity that this line passes through origin. It can come like this. Okay, clear? Yugandhar, are you clear that this line is not y is equal to x? Okay, this is just a line that's connecting these 2 points. Okay, I hope you understood the things. Next. Anyhow, if some of you have any, linear equation is of this form. Okay, but linear equation need not be in this form definitely. Okay, this is the actual form of linear equation, and this b need not be 0 all the times. Okay, linear equation is this, not this. This is just a a special case of linear equation where a value is 1 and b value is 0. Okay, so now what's the answer for this question? Please tell me quickly. It's 9:15. Again, I have a thermodynamics class at 10. So b is the answer. Straight away we discussed. Trapezoidal rule is of order h square. Simpson's 1/3 is of order h power 4, and trapezoidal 3/8 is of order h power 5. So you can see where is that option. One should go to q, one should go to q, means these 2 are wrong. One should go to q. Next, 2 should go to p, which is not here but it's here. So this is the correct answer. B is the correct answer. Okay, so it's 9:15. We'll end this lecture here. So tomorrow we'll, tomorrow basically, can we conduct one more session tomorrow at some time in tomorrow afternoon? Are you okay with that? Because we lost yesterday's morning session, so 2 hours class we lost. So can we conduct one more session tomorrow? I mean, morning session anyhow we'll have from 7:45 to 9:15. So tomorrow morning I have class. I have thermodynamics class from 10 to 11:30, so I can't take it. Okay. So afternoon probably in a time feasible to us. Yeah, I know EC and TBL guys, communications class is going on. So okay, at 4:30 again you have some other classes. Okay, we'll see. We'll discuss tomorrow morning. So I'll give some time slots tomorrow morning. So which is preferable, we'll continue then. Okay. Today there is thermodynamics class at 10 o'clock. I'll go for the things. Okay. So fine. Then we'll end up this class. Thank you all. Have a nice time. If there is any doubt, you can ask me. Otherwise, it's fine. Regarding the timing of tomorrow's class, we'll think. Probability notes I'll upload shortly. 2 days, maybe tomorrow or day after tomorrow we'll take. Okay. So thank you all. Have a nice time.